Hi everyone, this is Kasi Ramanathan. In this demo, I'm going to teach you how to fine tune a LLM locally in a Windows system. So normally we find lot of material to fine tune a LLM, but everything they will use collab space. So basically, it's a Google Cloud. So it has a GPU internally and also all the software available internally. So there won't be much challenge, but if you train a system locally, it's very challenging. I don't find any material, so I created a material myself. I'll be using this document. I'll share a document in the YouTube video. So basically, you should have WSL, that is Windows subsystem. This is basically a Linux system that will run in the Windows. I already installed, so I'll directly start it. I'll create a virtual Python environment and I will also activate it. Whatever the software that I download, I will download within the environment. AIENV, so it's active now. I'll start installing the software. I'm upgrading the pip, so I'm installing the PyTorch and the other software. That is that's a GPU version that will run on CUDA. So these are basically the PyTorch that is fine tuned so that it will run. It will use the GPU and run in CUDA. So what is a GPU and what is a CUDA? GPU is basically like CPU. So you also need a CPU and additionally you can have a GPU. So this GPU, it will run the task in a parallel fashion so that for fine tuning and all, it will take long time. If you have a GPU, it will be much faster. And CUDA, so CUDA is basically a NVIDIA software. It is there to utilize the GPUs. Let it complete. Once it completes, I will install the other set of software. So this includes Jupyter Lab, Pandas, Matplotlib, dataset transformers. Jupyter Lab is basically a IDE where I can write a Python program. I'll add CUDA to the path and will activate it. And I will also install a compiler that will package the Python libraries. Let it complete. So fine tuning is LLM is a basic part of any Gen AI layer. So it's the heart of any LLM. It is a basic activity where you teach LLM how to use your data. With your data, you are training the LLM. So here what I'm doing, I'm adding CUDA to the path and I'm activating it. I'll make a directory where I'll run the Jupyter notebook. My Jupyter notebook starter, this is the URL where it's available. I can use any one of this. I'll copy. From now on, I'll be running all the commands in Jupyter Notebook, not in the command prompt. I copy paste the URL. I'll run each of the commands. First, I'm installing UN slot. What it is? So this is a place where I will download the model. So I will download a model. I will fine tune it with my data and then use that model. This is publicly available models. So there are other places also. Hugging Face is one place where you can download the models. Okay, I'll rerun it. Here I'm reading the input data. So that is mx.json. We'll see what is there in that file. This is my data that I'll be using for fine tuning. This is about Mendix. Mendix is a low code, no code tool. This is a JSON-L file. So each and every JSON, we have it in a separate line. Normally, the data set, what they will do is that they will download from a repository, maybe some hacking page, something like that. But here I create a data set myself. So normally the document, right, we need to format in this format. So I don't want to write a Python program. I gave the document to the ChatGPT and I gave the model name and I asked it to create the input file based on my model name and it gave this file. So I'll be using this file. This file is already there over here. Okay, so this is complete. Now I will run this command. It's reading the file and storing it in the file variable. I'll print the first line of the variable to see what's the output. Okay, it's complete. Maybe I'll change and print the first line. I'm checking if CUDA is available and if my GPU is available. Print my GPU. So CUDA is available and this is the GPU that I have in my laptop. I'm mentioning the model name. I'll be using this model. So why I am using this model? There are a lot of model, right? ChatGPT is there. But ChatGPT, it doesn't allow to fine tune locally. You can use some older version of ChatGPT. So normally they will fine tune with Llama, something like that. But these are heavy models. You cannot fine tune it with your laptop. So I'm taking a tiny model. So this one I can easily fine tune in my laptop. I'm loading the model locally. Basically, something like you are downloading a file. You are loading the model locally. You are downloading the weights. Tokenizer. Tokenizer means it's the weight of the model. So now the model is available locally. Before I fine tune, I will check the model. So what I'm asking, so this is my prompt. Generate a detailed RFP with section on Mendix. What are the section? These are the sections. Project overview, technical requirement. I'm storing it in a variable and I'm putting it here or directly I can hard code it over here. Once I ask the question, it gives output. That output I am printing over here. I'll run this. I think this is not complete. I'll pause for some time. It will take long duration. I'll pause for some time. Okay, now it's complete. This model doesn't know anything about Mendix. I'm very sure that it's not trained using Mendix. So it hallucinates. It generates some information. So this is my user query. So it's giving about company, not about Mendix. For technical expert is, so it gives in-depth knowledge of Mendix platform capability, experience with latest Mendix version and feature. Everything is very generic, nothing related to the product. Okay, now we'll start fine tuning. For any fine tuning, first thing we'll start is we'll start with the data. I should convert the JSON file in a format that the model can understand. So that is the what I'm doing over here. I'm printing the first value to see how it is. So it will be something like this. So before it was a JSON, now I converted to input, output. So this model is expecting input and output. It's expecting question and answer, but we don't have any question, so that I am only using the output part. With this only, it's trying to learn. So I'm passing the model parameter. The model name I already stored. I'm passing this value and other parameter I'm passing. Just before fine tuning, this and all is done. Format data set, that is also done. So I'm using LoRa adapter. So what is that LoRa adapter? So LoRa adapter is a type of fine tuning where you don't adjust the whole model weight. To adjust the complete model weight, it will take long time. So basically, you update only fraction of the model weight so that it's you can train the model much faster and more effectively. So I'm passing all the model parameter. These are my training parameters. I'll run this. The training is happening. Here only I'm starting the training. It will take some time to complete so that I'll pause the video. So once it complete, I'll start the video again. Yeah. The training is still happening. So based on the training parameter that we provided, the epoch, the learning rate is doing the training. After the training is done, we are converting the model for it to serve. So for training, I will use a different model. For serving, I'm converting the model so that it will serve in a better way. Let the training completes. Once the training is done, then nothing. So we need to test the application and we'll see. Now it will give more contextual information related to Mendix. So before it doesn't know any information, it was generally giving some information like my company is do Mendix project like that. Now I'll get more accurate response. I'm expecting a more accurate response. I'll pass and resume once the training completes. The training is almost done. Guys, I will upload a document with this video. It will be very helpful. Else it's very difficult to train a model. I faced lot of issues and finally only I got the document. Finally only I prepared a document. I'll start running this. It's almost complete. Now I'm testing this with the same prompt. Previously I used the prompt, right? I'm using the same prompt and I am testing that. Testing the fine-tuned model now. Okay, done. So now this is also complete. I'm sending the same prompt. See, now I got some more meaningful response. The response is less, but it's more relevant. They're saying that Mendix is using microflow, nanoflow for complex business logic in Mendix. So microflow, nanoflow, and all is part of Mendix. So everywhere it's using microflow, nanoflow. Maybe my input data has that information. They're trying to use the information in all the places. Anyway, my model is fine-tuned. So if I use more larger data, I'll get even more better response. Thank you, guys.